Thank you so much for taking time out of your day to join us. I know today's speaker has been working very hard to bring you some great information. Before I introduce the presenter, a few quick items. We are recording this presentation and you will have access to it after we're finished. I'll go over where you can find those recordings at the end of today's webinar. Please feel free to interact with the presenter if you would like. You can enter questions in the chat box and we'll answer as quickly as we can. Today's presenter is Delta's Product Development Manager, Jacob Paso. And Jacob also does a lot of technical and application support for us here at Delta. And I'll let Jacob introduce today's topic. With that, welcome, Jacob.
Thank you, AJ. Welcome, everyone. Today, we're going to talk about using HMIs with RMC motion controllers. HMIs are also known as operator interfaces, of course. So let's get going. The typical situation in a machine is that we have a motion axis in the motion controller and a PLC controlling the entire machine and directing the activities of the motion controller. And then we have the HMI connected to the PLC. This is the most common configuration. So typically, the HMI is not communicating with the motion controller, and so typically you don't need to know so much about it. However, the RMC can be in standalone applications communicating with or controlling the motion axis and communicating directly with the HMI. In these situations, you certainly do need to know how to set up the HMI to communicate with the RMC motion controller. There are some cases in the above here where the HMI does also communicate directly with the RMC. So in that case, we also want to know how to set up the RMC to communicate with the motion controller. So these are the main configurations. Before we get into details, I want to mention that we do have instructions and example projects for some HMIs on our website, deltamotion.com. And if you contact technical support, we may have other examples that may work that are maybe not quite suited enough for use or for us to put on the website, but may work anyhow. Looks like the light turned off here and it's not turning back on. Oh, there it goes. So if we look briefly at our website, one moment here. So deltamotion.com, if we go to downloads page, we have examples here and we have HMIs. We can click that and we see some examples. We don't have a ton of examples because we're typically not so involved with HMIs as we are with like PLCs. Obviously, we have Automation Direct Seymour, old Easy Touch, ProFace. This is really old though. Red Lion, and look like we have Peak HMI. That's actually just a software HMI that runs on a Windows PC. So a few examples here. And again, if you contact us in technical support, we may be able to get further examples for you or help you get set up with whichever HMI you have. So when we talk about communication between an HMI and the RMC motion controller, it's all about reading and writing data back and forth. And typically we're interested in status of the RMC, seeing where it is, what it's doing, if there's any errors or halts. Parameters, maybe adjusting parameters on the axes, such as setting the offset if you need to calibrate your axis. Sending commands, reading and writing variables that are typically used in user programs inside the motion controllers. For commands, we can send motion commands or we can start user programs. And occasionally reading plots from the motion controller. Not many HMIs support reading plots, but it is of interest sometimes. When we're reading, we deal with data types. The RMC supports only 32-bit registers. So reals, this is a floating point number, double integer, so 32-bit integer, and then a double word, so 32-bit string of bits, typically represented in the RMC by 16-pound. HMIs may also use this, or they may use 0x something, or they may just represent it as an integer. So the key is here that the RMC does not support individual Booleans over the communications. So that means if you want the HMI to be able to read a bit, say like a status bit of in position, for example, it has to be able to read bits from within a 32-bit register. The RMC has a lot of communication protocols that can be used for communication. It must be, the HMI must be a master because the RMC is only a slave. Now this is normally not a problem because most HMIs are masters, although I have run into one or two that are not a master slave, and that of course doesn't work directly with RMC. But typically this is not an issue. HMIs are masters and can talk to lots of devices. So the protocols RMC support are listed here for Ethernet, and for serial we also have some, and then we have Profibus. It's its own protocol, of course. Serial and Profibus are kind of going the way of the dinosaur. We don't deal much with that anymore with HMIs. It's pretty much all Ethernet, but there are some older ones occasionally when you connect via serial or Profibus. Of these, the circled ones are the protocols that we typically use with HMI. So that's Modbus, either the serial version or the Ethernet version, or serial DF1, which is kind of an Allen Bradley protocol, or Ethernet CSP, which is basically DF1 over Ethernet. In fact, sometimes you'll see it called DF1 even on the Ethernet version. But these two protocols are pretty much exclusive use with HMIs and the RMC. Some of the others work. Ethernet IP gets rather convoluted and difficult when used with an HMI. The cyclic I/O on Ethernet IP works really, really well on PLCs, but typically not on HMIs, and Profinet is kind of a similar story. So now comes one of the most important parts of dealing with RMCs and HMIs, is how to determine if an HMI can communicate with an RMC. So the first part, of course, is the protocol. So if the HMI can communicate with any of these devices, an Allen Bradley SLC 500, Allen Bradley Micrologix, or a Modbus device, then it can likely communicate with RMC. The Allen Bradley SLC 500 Micrologix, of course, it needs to support the protocols listed here. So CSP or DF1 when it's dealing with Allen Bradley. It's happened that we've had HMIs that support only Data Highway Plus, and the RMC does not support Data Highway Plus. So these PLCs, plus it has to be over the DF1 type communication or a Modbus device. And what happens then when the HMI communicates with RMC, it's going to think that the RMC is actually a PLC, that it is an Allen Bradley SLC 500 or Micrologix or a Modbus device. That's how it's going to work. Beyond just whether the protocol matches, we need to look at functionality. Now, there are some HMIs that are designed with minimal functionality because they are expected to communicate with a certain PLC that has known functionality, so it's fairly limited. So you need to look for an HMI that has enough functionality. One of the first ones that's absolutely required is reading and writing floating point registers. So if you want to read the actual position in the RMC or send commands, you need to support floating point registers in the HMI. And typically most modern ones do. There are some I've run into that only support integers, are kind of rare. And it is actually possible to make those work with RMC if they support only integers. However, you generally have to only communicate with the variable table. We can set the variables to reals or integers. So we set them to integers. We can communicate with an HMI that only supports integers, but it's very, very painful because you have to have programs inside the RMC that are always converting to reals and back from reals to ints, and sending commands is really challenging. So in general, if you want any kind of reasonable experience, they have to support reading and writing floats. They also need to support writing blocks of registers. So this is for sending commands, like when we send the move absolute command, we send a number of 20, and then we send the position, velocity, accel, decel, and direction. So that's 6 registers that we want to send at once. And typically blocks of registers are sent via recipes or via scripting. So if your RMC supports recipes or scripting that can write directly to the external device, then it very likely fulfills this requirement. Some highly desirable functionality is that the HMI supports internal variables so that you can send commands with varied values. For example, if you create a button that sends a move command and tells it to move to position of 5, that's very fine. But you know, the operator, he may want to change that 5 to be 5.01 because it's not quite matching up with what he sees. So he wants to be able to change that variable. And if the HMI doesn't support it having its own internal variables where you can change what value is being sent to the RMC, that doesn't work so well. Or if you want to set a variable position offset, maybe you're doing the calibration, you're adjusting the 0 point, you write that to an axis parameter. You want to be able to change from the HMI exact to what you're writing. So some HMIs haven't supported internal variables in a way where you can adjust what we're sending. It's also desirable to be able to read bits in a D word. For example, the in position status bit or a halted bit, you may want to look at those. And to look at those, the HMI has to be able to read the entire status bits register and then pick off just an individual bit to give an indication of which one's on. And then some niceties. Many HMIs have a momentary button where you press the button, and when you press it, it sets a bit high, and when you release it, it sets a bit low. Now with the RMC, it doesn't support bits over the communication, so that momentary button, in order for it to work like for a jog where you press a button and it's moving, and when you let up, it stops, that momentary button has to be able to write a float or an integer when you press it and release it. And not all HMIs have this functionality. Another nicety is the ability to view plots. And with plots, we're not talking about trending where it's taking one sample every 50 milliseconds and slowly updating the screen, but we mean reading the array of data from the RMC and plotting that versus time. And not so many HMIs support that, but there are some that do. When we talk about reading and writing the RMC data, it requires knowing register addresses. So we're reading the actual position velocity from the various axes, reading and writing variables, sending commands. And of course, the question is, what is the address? To find that, we can look at the address maps inside RMCTools. Let's go ahead and fire up RMCTools here. I have my RMC70 project that we're going to be using. And if we double click address maps, we see that we have the Modbus address map. I click that, I see all the addresses in this RMC for Modbus. So if I want to look at maybe axis status, that is right here, axis 0 status registers, expand that. My status bit is this address. My actual position is down here. Or if I want to look at the variables, looks like that's right here. So variable 0 is this address here, and I can scroll down and find addresses for any variable. So that's how I find the addresses that I need to read and write from. DF1, we have similar. We have all the addresses there as well. Now you will notice that we have the indirect data map that we often use for PLCs. However, the indirect data map is not very useful for HMIs normally, because HMIs typically read items individually, not in a group. So you don't read from a big block of registers typically, so the indirect data map doesn't really help. And HMIs are generally reading at a slow rate, so we're not so worried about efficiency like we are in a PLC. So in the RMCTools address maps, we have the indirect data map. This one happens to be set up, but that's for something else. Normally, you don't bother setting it up for dealing with an HMI. I want to talk a little bit specifically about sending commands. You may have seen this like a move absolute as it's reported in the event log in the RMC. Each command has a command number. So the move absolute has 20. We see a start task command as 90. And then we have the parameters here. And those need to be sent to the RMC to the command area. And that's just an area in RMC, which its own regular addresses that you write to, like axis 0 command and command param 1, command param 2, and so on. And we write these values, so 20, 10, 20, 100, 100, 0, we would write that to the axis 0 command area if we want it to become a command. You'll notice the command area has 10 registers per axis. You only have to write as many as the command requires. So this requires 6, you only have to write 6. The start task command requires 3, 90, and 0, and the program number, you just have to write 3. So fairly simple, but you typically write it as a block at once. Important thing to know with HMIs and sending commands to the RMC. You need to write the parameters first, then the command value. So these parameters get written first, and then the command value, like 20, is written last. This is because HMIs usually write one value at a time. Even HMIs where it looks like you're sending a block of data, I've found that what they're actually doing behind the scenes is sending it one at a time, not in a block like a PLC would do. In the RMC, it executes the command when the command number is written. So if we would write the command number 20 first, the RMC would say, hey, we got a 20, we got a command, let's go execute it. And it hasn't received the parameters yet, so it's going to use the parameters from the last command you use, and that gets very confusing. So with an HMI, it's important to send the parameters first and then the command. If you're sending commands, of course, you could just write to variable and trigger use a program from HMI. That works just fine as well. But when you send commands, this is a very important concept to keep track of. So that's just a general overview of the HMIs. We have on our desk a couple of real HMIs that we're going to go through and set up here. We have a Seymour HMI from Automation Direct and a Red Lion HMI. They're both connected via an Ethernet switch to an RMC75E, and that RMC's address is 192.168.0.75. So we'll look at the Seymour first and go through a setup on that. So I will start a project here, and we have an EA7S6M, I believe. Let me double check here which one it actually is. Yep, it's an S6M. And let's call it new project 1 is fine. PLC protocol, we can choose one to start with. We can change it later as well. We will use the Modicon Modbus TCP IP Ethernet. And we can set up the protocol here, looks like. I'll click and I get to wait a little bit for the window to open. So 192.168.0.75 is the address of the RMC. Looks like the port number is right, byte order. Modbus a little bit annoying and needing to set the word order. I believe this is the right order. We have an example on our website, some explanation on that in case person doesn't know. And these function codes for reading and writing look fine. Looks like that's all. Okay, and okay. And so it will set up this project a little bit. Now I'll go back to the setup communication. So Ethernet ports device 1, this is the one that we just set up, and I'll rename this to something that makes sense. So I'll just call it RMC75E, and those settings still look good. So we have the HMI knowing about an RMC is talking to. Next, we want to set up some tags. So we go to the database menu, tag name database, and a tag, that's just a reference to a register in the RMC or to an internal one in the HMI. So we are going to add a tag. Right now we have some system tags in this HMI, but we're not going to look at those. We'll click add, and I'll use it from the RMC75, and we'll say axis 0 actual pause, act pause. That's going to be a floating point value. Memory type is 4. All the memory types in the RMC for Modbus are 4. And the address, that's axis 0 actual position. Let's go look up what that is. In the address maps here, we have Modbus, and we go to axis 0, right there, actual position. So that's 404113. We just have to remember the 4113. So let's go back there and enter 4113, add, and let's add another one. We'll do axis 0 in pause. and that will be a bit, so a discrete, and I think we do 4. And let's see what that address was. Status bits, that's 4097. So we go 4097, and in pause is bit 0. Add that and close. Okay, so we have a couple there. Now, it knows about those tags. Now we should be able to set an object here in the screen that looks at that. So we'll go to Object, and we'll choose Indicator, and we'll use Numeric Display. We'll make it fairly big so we can see it easily. And wait a little bit. So let's see, we'll do text size a bit bigger here. That should be good. And data display tag, we will choose axis 0, act pause. Number of digits, we want to look at a few decimal points, so 3, 5 total, that's probably fine. And I think that's probably good enough. We can do all kinds of other settings for color and prettiness and so on, but that should be enough there. And then we will add an indicator that's a discrete, like an indicator light. So let's see, we'll set that one up, and that one will be axis 0 in pause. And we'll edit this here. We'll say in pause on and in pause off, just so it's easier to know what that is. That is in pause. Click OK. So now we have display for actual position, display for the in position bit. Let's go try sending that to the panel and see what happens. I think I'm all set up to connect. But we can go here, panel information. So it looks like it is connected just fine. So we'll send the project to the panel. I'm connected to the panel via USB from this computer here. So we're transferring to USB. And we'll do transfer. I guess it wants to save that. That's just fine. So wait a little while as it transfers the project to the panel. Transfer OK, close. And then we will look at the camera here. Okay, so this screen on the left, you can barely see it. The light's a little bit bad with that HMI. But we have the actual position here is 1, in position is on. So let's open RMCTools and make a move for that axis. So we'll move towards 15, and we'll move fairly slowly here, speed of 2. So now, yep, we see the HMI is moving, and the in position is off because it's moving. Once it hits 15, the in position should turn on. There it turned on again. So we see this HMI is actually working. So that's a very good sign. It's always nice. Usually when a person starts out, it doesn't work that well. There's always some troubleshooting, debugging to do. But let's add a button for a command. So that means we'll have to go to the tag name database and first tell the RMC that there's command registers in the RMC. So we'll add here, and we'll choose the RMC75E. We'll say axis 0 command, and that is a floating point. Memory type 4, address, let's go look that up in the address maps. Modbus, we have command area right here, looks like. Expand that. So 1025 is axis 0 command, and then the parameters. Notice that this increases by 2, 1027, 1029. That's because Modbus is a 16-bit address protocol, and we're using 32 bits, so we skip every other one. So 1025. So this is 1025. We'll add that, and then we will add command param 1, and that will be 1027. We'll go like this, so it's a little faster. Add, and then command param 2, and that's 1029. And then we have command param 3, that's 1031. command param 4, 1033, command param 5, 1035, add, close, and let's double check that. We have the command 1025, command parameter 1, 2, 3, 4, 5. This is enough remove absolute command. If we did a larger command like curve start advanced, we'd need more parameters. But 10, 25, 27, 29, 31, 33, 35, that looks right. So now we've added those tags, click OK. And on this RMC, we can use an object. Let me see which one it was, a recipe. Let's do a recipe, put that there, and wait a little bit as it pops up. So on the recipe, we can do some text. We can say move to 1. And on the recipe here, we need to choose which items to write. So we'll add, and we'll use access serial command, and we'll write a 20 there because that's a value for the command word. And then we'll use access serial, or we'll use command param 1. And we will write, let's see, what position were we moving to there? I forgot. We'll do a 1. And we'll add that. Oh, I forgot to add that other one. So access command 20, I have to click add, and then it will add that. Okay, there we go. And command param 1 and command param 2, that's going to be a speed. Maybe we'll move to speed of 2. Add that, and then command param 3. That would be the Excel. 20 is probably fine. And command param 4, that's the D cell. We use the same 20. And then command, I keep forgetting to press add there. 20, add. And then the last one is the direction, which for a linear axis is always 0. If it's some other value, it doesn't care. Add and close. So let's check it here. X0 command, move command is 20. We're moving to a position of 1 at a speed of 2, Excel D cell 20, 0. That looks all right. So we'll click OK. And now it should be able to send the project to the panel. Click transfer. Close that and see what the video says. There we see we have that new button. It says move to 1. If we click it, or we can't click it on the screen, I have to press it with my finger here. So I'll press move to 1. And let's see, in RMCTools, we got an error. So let's see in the event log, invalid command parameter 3 accelerate. So looks like I didn't write anything to those. Now, do you guys know what the problem was? Here I was telling you, and I did the same thing myself. Let's see if we can fix that. Double click this, and it'll take a little while to pop up. On the recipe, I sent the access 0 command first. That's entirely wrong and backwards. So let's see if we can move that down. Move it to the end. Yep. Okay, click OK. Now we'll send that project to the panel. Transfer. It's initializing. It should set up here pretty quick. And let's try this. So if I press that, move to 1, look at that. It's moving, the position's off, and we'll probably get to position of 1. Sure enough, there we go. So live example of why you need to make sure you send that access 0 command last. And one thing we can do is look in the event log when we're doing communications. So we see here, for example, the TCP/IP connection opened, protocol Modbus TCP, and we got a command, we can look at the event log properties for troubleshooting. If we go to communications, Ethernet, open all application transactions, click OK. This can become a little bit difficult because we see all these reads going all the time that it's doing. And if we send a command, we can usually see that come through, but then we have to stop it very quickly. So I'm going to do this. Well, we'll move here to another position, I guess, first. Okay, so if I, on the touch screen, press move to 1, we'll see it come through very quickly on the event log. So I'll press that, and then I pause the event log, and now I scroll down to try to find that. Okay, there we go. So I received this one. Oh, you know what? I think maybe I missed it somewhere there. Let's see here. If I do a page up. There it was. Okay. So we should see here that we received a Modbus request, read holding registers, command received. Oh, that was a USB monitor. I need to find another one that came from Ethernet. Let's see. Scroll up a little bit more. There we go. Okay, so we have a lot of Modbus requests. They're reads, and then we see we get a Modbus request received, and there's a bunch of writes here. And we'll see that it wrote to these addresses 10, 27, 29, 31 that we set up for access 0 command parameters, and then it got the last one to 1025, which was to write the command, and at that point the RMC executed that command. So you can see with this, if you're doing writes to the right addresses and the length and so on, and the source, the IP address is coming from. So good tool on the event log for troubleshooting that. I will go back into the settings and on the communications, Ethernet, turn off all application transactions because it just floods the event log when I don't need it. And we'll start running that again. I will, on the CMOR, open up a more complete example here that has already been set up. It has a couple of buttons. There's a move to set point button. That's a recipe that does a move absolute command just like we already saw. And in the recipe, we see it writes the parameters and the access 0 command last as is proper. Well, let's see, if I go back in there, we will see that this one doesn't write just set values like we had set up in our example. This one uses variables. So these are internal HMI variables that it's using. So set point and speed, and the set point and speed can be set with these buttons here. These are data entry items. So you can set it and then move to that one. And same here with open loop, you can set the volts and move to open loop because that recipe is using that variable. We also have an enable controller command, an open loop halt command, and some more status, but we're doing the same thing we did before, looking at the actual position or the control output, the entire status word, displaying that as a hexadecimal. Let me go in there and show you that. So this one is, the display format is hex. Because it is just a D word, and then it's showing the individual bits on that. So if we send this project to the panel, this one should already be set up to communicate with the right RMC. Address is 75. Wait for it to transfer a little bit here. There we go. And if we look at the video here, we see the HMI is initializing, and now we have this. It's fairly hard to see, but I have the move to set point button here, and I can adjust the set point. So we'll set the set point, maybe we'll set it to 5, and we'll press enter. So you see it, well, actually I hit the wrong button. It's a 6 there. And then the speed, we'll do 3. I'll try to get that right here. Okay, and now if I click move to set point, we will see the actual position move to 6. So that's how you use an internal variable in HMI. Now I do believe it's possible, instead of using an internal variable in HMI, sorry, wrong one there, for the set point and speed, you could actually use variables in RMC to store the set point and speed. Which one you use is totally up to your choice. I do believe these may have an option for retentive where you can save it in the HMI. Can't find anything here, so I don't know if it actually is or not. But that's one thing to look at. Does the value get saved in the HMI? In RMC, you can make your variables retentive there. You can save them. It may be in the database tag name database where you set up whether it's retentive or not. I'm not sure about the details on this HMI. So this was just a simple example of setting up an HMI. I would also like to go through a Red Lion example for you as well. That's a little bit more capable than the Seymour. The Seymour is fairly inexpensive HMI, easy to use. So here's a Seymour, or sorry, a Red Lion G308. This software is not the latest software, but the latest software is still very similar. So we have a 308, and to start with, we go to network, protocol 1. We select a driver here. Let's go pick, and we'll do the Allen Bradley DF1 master. How about? I believe that is what we want there. And now we can rename this here, RMC75E. And we will tell it that it's a micrologics. I prefer the micrologics with SLIC because you can address items as F registers, which is a float, or L registers, which is a double integer, also works for D words. So if you want to address the status bits, something, the L works very well. So we'll do the address 192.168.0.75. And I believe that's all the settings we need. So now we want to go to some data tags, set those up. We'll do a new numeric tag, and we will call this one axis 0 actual position, act pause. And the source is going to be the RMC75, and that's going to be a floating point, and the address is F something. So let's go to our address maps and look that up. DF1, we have F8:8 is actual position. Click OK. And let's see, treat that as floating point. Wonder if there's any other settings we need here. And that looks good. And let's go do a flag tag status bits. So we'll choose that to be RMC75E. We'll pick floating point 8:0 as a status bits. Just remember that. And oh no, we ought to do this. Let's see, I thought I could set that up as a discrete. Let's see if I can't. Maybe if I do a long word, F8, I'm not sure that will work. Well, let's see here. If we do bits, that's B, floating point. There was a way to do it here. Bits. Oh well, we'll scrap that. I'll have to go look at my example to figure that one out. Let's add some tags for the commands. So F, and then I think that was 25:0. Let's check that out. Yeah, 25:0. So we'll do 25:0 is the axis 0 command floating point. Let's rename this axis 0 act pause. Sorry, that was the wrong one. Axis 0 command is much better. And we will add, let's see, I think we can do this smart duplicate. So that's param. And I believe what happens is it automatically increments that register, sure enough. So we'll smart duplicate again. Actually, that'll be off a little bit, but we can do that. A nice handy feature to do a smart duplicate like this. But I got my numbering off a little bit. So let's see, 1, 2, 3, 4, 5. That one's too many. We don't need that. So I'll go and rename that to 5 and 4 because we're off one here. And rename that to 2. This one to 1. There we go. And now we go to the display pages and actually put something on. Let's see here, 1 second. Okay. So here we have on the right-hand side primitives. These are the objects that we can put on there. If we go to, I believe it's core primitives. Let's see. I wonder what it was, if it was, I don't quite remember exactly. If it's text, no, maybe not. Let's see, I don't think I got a source there. On this one, I go to the data tags there, and I can drag the actual position out there, and that will display it. Let's see what I have for settings here. If I double click it and wait for the settings to open, axis or actual position, we'll make that a little bit bigger so we can see it just fine. And the tag, I don't think I have anything else. Format, the labels defined by the controlling tag. So we're gonna have to go look at that tag to make sure it's what we want it to be, because right now it's like it's just going to display something without any decimal points. So if we go to the data tags, axis 0 actual position, format there. Okay, format type pick, numeric, okay. And we want 2 digits before the decimal place and 3 digits after the decimal place. Okay, so now if we go back to display pages, the main page here, that one will display as we want it. So to send this down, we go to the link and do a send. It takes a little longer to do the first send right now. Later we can just update it. So if we look here, we see now this screen, axis 0 actual position, it's showing a ... Apparently it is not getting any communication with the RMC. Let's see if the RMC says anything. Tough telling from that. We'll double check here to make sure we have the right address. 192.168.75 is where we're at here. And if we look at the Red Lion software, we should be able to go to communications, 75, 192.168.0.75, micrologics, that should be fine. And the data tags here, axis 0 actual position is F8:8. So I guess I'm not entirely certain why it's not reading that value. I believe my Ethernet connections are all good here, I think. Actually, I'm having a little bit of problems with the it's not giving me a light on the transmit receive on that HMI, which is a little bit crazy because it was working not so long ago. Sure enough, we got an issue there. I'll try a different cable. One moment here. Let's see if the cable will fix it. Looks like the cable didn't fix it. I'll cycle power to the HMI. And this, of course, is not what's expected during a webinar, but this is actually what happens in real life. A very normal kind of a circumstance. So we will look at that thing. Okay, it powered up, went there, and still not working so well. I'll try the auxiliary Ethernet port on this thing. Let's see if that works any better. No, that is not working any better. So apparently I can come to the conclusion that right in the middle of the webinar, my red Lion quit working. The computer is connected to it via USB. But it's the Ethernet that actually quit working, and I'm not able to fix it at the moment. So I'll describe a little bit about what the Red Lion HMI is able to do here, because it's quite fully functional. And to do that, I will go to a project that we already have set up. So we say the display page here, the main one, we have a full example here. So we're displaying the actual position, which is an example I was just going through, although it isn't working. And the control output status, we can look at individual bits. And let's go see in the data tags how we did those individual bits here. And again, this is in the example we have on the website, so you can go there and look at it. So access 0 status in position. So that's an RMC75E F8:0, treat as bit array little endian, and picked out bit number 0. So that's how we pick out just the bit on that 32-bit registers, and it looks at the in position status bit. So in the display pages, we see that that's how we do the in position status bit there. Now we have these buttons, move to set point 1, move to set point 2, and so on. If I double click this button and look at the properties, we can see that what it's doing is calling a user, or not a user program, a program that's called here. And that's on the action tab. So when you press it, you can call a program called set point 1. And then we see in the move to set point 2 button, if I double click that and look at the properties, that one will call a different program called move to set point 2. So in the action is move to set point 2. So to look at what's happening there, we can go to the programs. And here we have a set point 1 program. And this one has a few steps, fairly simple. It's using this command called force. That's forcing the HMI to write a value to the access 0 command param 1. And it's writing this internal variable set point 1. And then we write command parameter 2, 3, 4, 5. And then we'd actually do the move command. And remember, the move command is last. And this is our example you can get from the website. And it says command parameters must be written before writing the command number. And then there's other ones as well. We have a jog forward program that does the exact same thing. It just moves it to a different, to a set point here, a certain speed So this is a move absolute command with the command number 20. And then a jog back does the same thing to a different position, command 20. The cool thing with using some programs for a jog, which the programs themselves aren't jog, they're just move commands. Actually, there's a jog forward, jog back, and then there's a stop. The stop does a stop command close loop. That's a command number of 6, and it's decelerating at 100. Now on the display pages, if we look at this jog backward, jog forward button, this is a momentary button. So when you press it, it's going to send a command to the RMC. So we see in the action here, on press, we will send the jog forward program or run it. And that, of course, will send a move absolute command to the RMC. When you release it, it will send the stop command. So it will stop the axis. So really good for doing a jog command that where you press the button, it's moving, and then when you release the button, it actually stops. Otherwise, we have normal functionality here. Got a button to go to the plot screen, and this RMC does support displaying plots of motion from the RMC. So we have a button get plot. We can actually save that plot here. That's kind of cool. And the get plot button, if I double click it here and wait for the properties to come up, we should see what it does. So on the action, it just runs this program called get plot data. If we look at that program, we can see that the get plot data, let's see up there, it's a little bit longer, but what it's doing is just reading data from the RMC. So RMC 75 plot 0 set 0, that's a tag that we set up in here, and that's pointing to a place in the RMC, and it's reading the length defined by plot length. So plot length is 1000, so it's reading this array, and it's doing that for set 0, set 1, and set 2, which is supposedly going to be the target position, actual position, and control output. And let's see, once it reads that, then looks like it's just doing a loop to actually take that data and put it in the format that the HMI needs, which is actually integers. So it's converting those to integers, look like, so it can be displayable. But really cool that it has this functionality, and it works quite well. Unfortunately, I can't display it because my HMI broke. But if we look at the screen, or if you click get plot, it will take a few seconds for the HMI to read from the RMC and then display it. I believe that covers all the details I had here. Let's look at the display pages again here. Make sure we got everything. So the items I've gone through cover pretty much everything: setting up tags, reading floats, writing commands, reading bits. I didn't talk about writing bits. Being the RMC does not support bits over the communications, it's rather difficult to write bits. What you can do is make sure you read the value from the RMC, modify just one bit in the 32-bit register, and then write it back again. We have to make sure that nothing else is accessing that during the same time. That's really hard to do with an HMI. So typically we try not to write to bits. Generally, you can set up a variable and just write that variable be 1 or 0, or maybe have only a bit defined in there that you know the HMI is only writing to. And then, of course, we talked about recipes and scripting for sending commands, and then reading plots as well. So with that, that just about covers it. I will point out that we use hardware HMIs here. There are software HMIs that just run on a PC, and those work just as fine as well. And normally the setup is very similar. The software between various HMI packages can be extremely different. I've just showed you a couple of them here, and these are just very easy to use, nice ones that we sometimes recommend to customers. Many of our customers who do larger machines, they have their own knowledge for lots of other HMIs that they use. And of course, you can use many different HMIs with RMC, not just the ones that we demonstrated here. So with that, I thank you. Let's look at the questions box. There is one question I got up here. So So there's a question here. What are the advantages and disadvantages to Modbus versus IEC? So for the RMC, we have internal addressing that you may have noticed in the address map. We'll look at that here. So the address map, you see we have the IEC protocol or addressing. The IEC addressing is only used internally in the RMC. There isn't anything like an IEC protocol that we actually use. So for communicating, the IEC really doesn't count. So it's basically kind of a moot point as far as protocols. Now the addresses you'll see are very similar to what we have for DF1. And the IEC, the two-level addressing 7.0 or 7.1 and so on, is something we use on a protocol called DMCP. It's a Delta Motion Control Protocol. We made it up ourselves, very simple. And we do use that for like the Mitsubishi protocol, kind of internally, it's hidden from the user. And we have an example for communicating with the RMC via a C in an embedded system, for example, that you can implement DMCP. But otherwise, IEC isn't really used for communication. Any other questions before we close today? Can you recommend an HMI capable of plotting, for example, position versus time in real time? A standard hardware HMI or even software HMI, just kind of a normal one that's has similar setup to what we have now. I don't know if anyone exists. You basically have to get something like a Windows CE or something that supports maybe just full-blown Windows or something where you can actually program your own application in there, because it requires a lot of processing, a lot of high-speed data to actually be able to trend a plot or really upload it in anything relative to real time. So the short answer, I can't really do that. You know, kind of a different thing is just use a PC, and we actually have some example projects in, let's see, I think Visual Basic, and we maybe even have in C++ that actually trend a plot in real time and allow you to save that plot in a format that RMCTools can later open and view. So that would be a different way of doing it, not necessarily an official HMI per se. Any other questions? Yeah, okay. I'll stay on just a little bit longer. I know sometimes it takes a little while to formulate a question and ask it. If it does, you can just say, hey, I got a question. I'll ask it here, and I'll wait a little bit longer. Okay, another question. Do you know if ProFace HMIs have the ability to read plots like the Red Lion? That I do not know. I haven't looked at ProFace for a long time. Way back in the day, they had a nice interface that was very flexible. They changed it and they made it rather difficult to use with RMC. I haven't looked at the software recently to know if there's any updates, but I know years ago, I don't believe it supported it. There's a chance that it actually does now. I know they added some functionality on that one, but unfortunately, I'm not familiar. It would be kind of fun to download a software and see if it looks like it supports it. Any other questions? Okay, well with that, I thank you for attending Delta's webinar. AJ, do you want to say any parting words?
Well, I want to thank you, Jacob, for the great presentation today, and thank you to all of our attendees. We know that your time is valuable, and we appreciate you taking time out of your day to see the information that we have to present. So thank you very much. Just wanted to remind you, Jacob mentioned it during the presentation, deltamotion.com is the resource for a lot of information. We mentioned the downloads page that has examples. We encourage you to go there, and that also gives you the opportunity, there's the opportunity there to connect with our technical and application support folks. You can ask questions there as you think of things, as things come up. Recordings will be available at deltamotion.com/webinars. That's kind of the central page where you can register for upcoming webinars. You can also see recordings and links to recordings there. We also post them at forum.deltamotion.com. There is a topic in the forum for Delta webinars. You'll see that if you go in there. If you don't see it, you can search very easily for webinars and we'll bring that topic up for you. And then finally, we also post them to our YouTube channel, which is Delta Motion Control, all one word. So if you search for Delta Motion Control, you'll find our content there on YouTube.